Okay, hey sixth grade, and welcome to today's video tutorial. Today we're going on to 2.3. Chapter 2 is still fractions and decimals. Okay, we're still on fractions and decimals. And section 3 today is on dividing mixed numbers. Dividing mixed numbers. Okay, don't forget your name and the date. And our learning target today is I can, pretty similar to before, but just divide mixed numbers and explain. Okay. First thing says write a short story that involves dividing by a mixed number. So pause the video and see what you can come up with. All right. One example that I always like to use when I'm thinking of fractions, one of the places I see them most common in the real world is cooking. Okay. And maybe you don't have to do it a whole lot now. Maybe mom, grandma, dad, grandpa, whoever cooks for you a lot, but someday you're going to have to cook. And I like to use cooking examples a lot when dealing with fractions. You know, whenever you're baking or using measuring equipment, anything like that, you're going to use some type of mixed number fraction is my guess. So maybe I'm going to write a story about, my family loves cereal. A serving of cereal is 1.5 cups. Total in the box comes, I don't know, maybe 25, something along those lines. I have no idea. I'm just kind of throwing a few numbers out there. Is there enough cereal to eat for 2 weeks if just I'm eating it? Okay, so you'd have to use probably some type of division here, taking your total cups, so 25, and then dividing it by your servings, something along those lines. Okay, maybe you wanted to talk about something else with your mixed number problem, but I usually think about cooking. Okay, to warm up today, you will start with writing improper fractions as mixed numbers. You'll have to do this quite a bit and be able to do it in reverse as well, going from a mixed number to an improper fraction. So why don't you pause the video and try this out. Okay, hopefully you remember kind of the process of doing this, but basically you're asking yourself, how many times does 5 go into 12? Well, 2 whole times, and 2 times 5 is 10. There'd be 2 left over to get to 12 and keep your same denominator. So 2 and 2/5 would be our answer for that first one. Okay. Kind of similar, 4 goes into 21 5 whole times, which is 20, and you'd have 1/4 left over. 9 goes into 16 just once, and there's 7/9 left over. 6 goes into 27, let's see, 4 times. 4 times 6 is 24, so we'd have 3 left over. 3, 6, which is the same thing as a half. So 4.5 in most simplest terms. Okay. 3 goes into 80, quite a few times. Let's see, if I were to times it by 20, that would give me 60. If I times 3 by 25, that would give me 75. Can it go in there again? So can I go in there 26 times? Well, let's check. 26 times 3. That would be 18. 678. Good. So 26 whole times, which is 78. And then I have 2/3 left over. 2 to get to 80. And then 3 is my denominator. And lastly, 9 into 55. How many times does 9 go into 55? Well, 9 times 5 is 45. 9 times 6 is 54. So I'd only have 1 left over to get to 55, keep my denominator. All right, hopefully that's a little bit of a review today for you, but you'll have to do that here in this section. All right, a key idea for the day says to divide mixed numbers, what you need to do is write each mixed number as an improper fraction, and then divide as you would with proper fractions. Remember, an improper fraction is where your numerator is greater than your denominator. So, for example, if we had something like 7/5, that'd be an example of an improper fraction. Our numerator is greater than our denominator. Okay? So first, write your mixed number as an improper fraction, and then divide as you would with proper fractions. We just got done with that section. Remember, when you divide, you actually don't even, when you divide fractions, there is no division going on. You're keeping the first fraction the same, flipping your division to multiplication, and then switching the next fraction to its reciprocal. Okay, inverting it. So the numerator is the denominator, and the denominator is the numerator. Let's try example 1 together. It says 2 1/4 divided by 3/8. Okay, from our key idea, our first step is we need to make this into an improper fraction. If you remember how to do that, take your whole number times your denominator. 2 times 4 is 8, and add your numerator. So 8 plus 1 would be 9. So this would be 9, and keep your denominator the same, which is 4. So 9/4 divided by 3/8. Okay, now, second step, just divide as you would with proper fractions. So I'm going to write myself a little reminder of keep flip-flop. Keep my first fraction the same. Okay, 9/4. Flip my division to multiplication and flop this last fraction to its reciprocal. So that would be 8/3. Awesome. I see that if I look diagonally, I've got quite a few ways that I can simplify before I multiply, making this a lot easier for myself. So 8 and 4 have a common factor of 4. If I divide each by 4, I'd get 1 and 2. And 3 and 9 have a common factor of 3. Divide this by 3 is 1. Divide this by 3 is 3. That all of a sudden became a lot easier. 3 times 2 on top gives me 6. 1 times 1 on bottom is 1. Anything over itself is itself. Anything over 1 is itself, excuse me. So my answer, 6 divided by 1 is 6. Okay. So that's kind of the process that you will follow for this section. Here I've got a situation where I have 2 mixed numbers. So I need to make both of these into improper fractions. So whole number times denominator, 3 times 6 is 18. Plus 5 would give me a total of 23. So this is 23/6, keep my same denominator. And again, this is a mixed number, so I need to change that as well. 1 times 3 is 3, plus 2 is 5, so divided by 5/3. Next, I'm going to keep flip-flop. So that gives me 23/6, keeping the same. Change division multiplication, and change 5/3 to its inverse, so 3/5. I see that I can simplify first. So 3 and 6 have a common factor of 3. Divide each by 3 would give me 1 and 2. Okay, multiplying across now. Numerator times numerator, 23 over 2 times 5 on bottom is 10. Lastly, change this back now into an improper fraction. So 2 goes into 23, or 10 goes into 23 a total of 2 times, which would be 20. And I'd have 3 left over to get to 23 and keep my denominator. So 2 and 3/10 would be my answer. Okay, next up is the Oyos. Please pause the video to try these examples and hopefully come up with the same answers as I do. For number 1, I get a total of, let's see my pen, here we go, 2 and 1/7. Number 2 is 2 and 8/9. Number 3 is 5 and a half. And 4 is 3 and a fifth. If you didn't get that for any, please rework the problem or come ask me for help if you need it. Moving on to example 3, we can't forget about order of operations. From here on out, we still need to remember that there's a specific order in math, and if you see division and subtraction in the same problem, remember you need to divide first. PEMDAS says, parentheses, first, then exponents, multiply, divide, left to right, add, subtract, left to right. So multiplication and division come before addition or subtraction. Okay, my first step, I'm going to change my mixed numbers to improper fractions. So I get 5 times 4 is 20, plus 1 is 21/4. And my other mixed number is 8 times 1 is 8, plus 1 is 9/8 as an improper fraction. And I'm going to multiply by the reciprocal, so I'm going to switch that right away to 8/9. All right, I'm actually going to simplify now before I multiply. And I see that 21 and 9 can both be simplified by 3. Divide by 3, this is 3. Divide by 3, this is 7. And 8 and 4 have a common factor of 4. Divide each by 4 would give me 2 and 1. Now I multiply across. 7 times 2 gives me 14. And 1 times 3 is 3. Okay. Next up, I need to subtract by 2/3. So I'm going to take my 14/3 and I'm going to subtract 2/3. I already have a common denominator, which is really nice. I don't need to find one. I'll keep my common denominator, and 14 minus 2 would give me 12. And then just simplifying, 12 divided by 3. 3 goes into 12. This is perfect. A total of 4 times, which is nice. A lot of times in math, you'll see these what look like confusing mixed number problems, okay, where it's, a lot of information. 5 and 1/4 divided by 1 and 1/8 minus 2/3. That kind of looks rather complicated, but in the end, we get a really nice whole number. You'll kind of see that as a reoccurring theme. Real life example is kind of similar to what I talked about before, where you see this a lot with cooking. It says 1 serving of tortilla soup, yum, is 1 2/3 cup. A restaurant cook makes 50 total cups. Is there enough to serve 35 people? And explain. All right, well, if our total is 50 and we divide that evenly into 1 2/3 cup per person, let's see how much that gives us. Okay, remember to first change this into an improper fraction. So 3 times 1 is 3 plus 2 is 5/3. Also remember that 50 as a fraction is 50 over 1. So keep my first fraction the same. Flip my division to multiplication and my next fraction to its reciprocal. So that would be 3/5. Before I multiply, I'm going to simplify. 50 and 5 have a common factor of 5. So I can divide by 5. 1 and 10. Now I can multiply across. 10 times 3 gives me 30. Bottom, 1 times 1 is 1. 30 divided by 1 is 30. So if I were to evenly divide my total into 1 2/3 cups, that would give me 30 cups. So is there enough to serve 35 people? And explain, no, there is not, because there's only 30 cups if you were to divide each one into 1 2/3 cups. And we needed a total to serve 35 people. We only had, actually, I should probably say 30 servings maybe, but we needed 30 to serve 35 people, and we can only serve 30, so we are 5 short. Okay. Lastly, go on to apply this using PEMDAS and dividing mixed numbers. If with the on your own problems, pause for 5, 6, 7, and 8 and see what you come up with. Okay, our correct answers, you should be getting 8 and 1/8 and 4 and 8/9 for number 6. Number 7, you should get a total of 2. And number 8 should be 1/3. Again, please come see me with any questions that you have. Hopefully this makes sense, and good luck on the homework.